Good morning, kids. We're going to take our motion graphs a step further today, and we're going to add a new type of graph today, velocity versus time. Kinematics, the study of motion, is what we've been looking at, and we're still in that subject, and we're going to remind ourselves that graphs are a great way to represent motion in physics. It just gives you a whole lot of information in one small picture. So remember that for an xt graph, displacement versus time, the slope is equal to the velocity because that's your change in displacement over change in time. So that is our basic velocity definition. And remember that the slope of this part, this entire section, because it's a straight line, that slope is exactly the same at 1 second, 2 seconds, 3.6 seconds, 4.9 seconds, all along until you get to 5. Remember that the slope also tells you the direction. So if you have a positive slope, that means that you have a positive velocity. And remember that the velocity direction is indicated by plus or minus. So this whole section has the same exact velocity along that whole time interval. So from 5 to 10 seconds, you have the same velocity, and you should be able to see that that is negative, which means it's moving in the negative direction, or backwards is another way to say it. Remember that a horizontal line on an xt graph means that the slope equals 0. So v equals 0, so it means that it's just standing still. So we just figured out the slope. You could actually go through and calculate the value for that. And if they ask you, so for example, if they ask you, what is the velocity at 2.5 seconds? It doesn't matter if it's 0.1 or if it's 4.99999. All along that line is the same velocity. So you can just pick any 2 points. So for our example over here, we just chose this point and this point. Okay, so you'll end up with 4 over 5 or 0.8 meters per second. And again, it's a positive slope, so it means it's moving to the right along this portion. So here is an open-ended question. I need to switch it to student view, or maybe not. Okay, so they ask you to calculate the velocity between 30 and 40 seconds. So between 30 and 40. So you're looking at this segment right here. You can figure out the slope using any 2 points along that line. Try and find that out and input that. Okay, so we're back. Again, on a distance or displacement versus time graph, positive slopes mean positive direction movement, and negative slopes means they're moving backwards or in the negative direction. Remember, the steepness of the slope is going to give you different values. So if you have a line that's going like this and you compare it to a line that's going like this object is moving faster because it has a bigger value. Okay, when the object crosses the x-axis, all that means is that it's just returning to the origin, or it's passing through the origin. And you get to pick where that origin is. That just means it crosses over. Okay, so there's a short video. You can go ahead, hit play, let that play through. Well, I'll do it now for you. Here you go.
Thanks for stopping by. I'm Virgil Ricks, and this is 2 Minute Classroom. Today we're talking about motion. Specifically, we're talking about speed, velocity, and acceleration. And let's clear up a few things right off the bat. First of all, speed and velocity are different, and acceleration is much more than just speeding up. Speed is the rate at which something changes its position. It's represented as distance over time. Miles per hour, kilometers per hour, meters per second, these are all examples of the units for speed. So if you're driving in your car at 72 miles per hour, then that's your speed. In fact, it's your instantaneous speed, or your speed in that exact moment. If you get to the end of your trip and realize that it took you 2 hours to drive 120 miles, then your overall speed was 60 miles per hour. And this is also known as your average speed. Velocity is a lot like speed, except for one important difference. It's a vector, which means it has a direction attached to it. So while your speed may have been 72 miles per hour, your velocity was 72 miles per hour east, or 72 miles per hour towards the beach. There just has to be some direction attached to the speed to make it a velocity. With that knowledge in hand, you're now ready to understand acceleration, which is simply the rate at which velocity changes. It's represented as distance per time, or distance per time squared. For example, meters per second squared are common units for acceleration. Anytime you change your velocity, you are accelerating. That can be speeding up or slowing down, which is also known as negative acceleration. But direction is also a component of velocity. So when you change your direction, even if your speed doesn't change, you are accelerating. Does that blow your mind? All right, let's recap. Speed is the rate at which something moves, distance over time. Velocity is speed with a direction, so distance over time with a specific direction. And acceleration, the king of them all, is distance over time squared, or the rate at which velocity changes. So whether you're speeding up, slowing down, or changing directions, you're changing your velocity and thus accelerating. Science is so cool. I hope you enjoyed this video. Feel free to throw any comments below, whether it be questions, criticisms, or just idle chit-chat. I'd love to hear questions. Free to throw. I hope you enjoyed. Science is so cool. Science thus accelerate.
Okay, so kids, I want to just specify something. I don't like this. I like this. It has a magnitude and a direction. So if you're putting that down in your notes, which I hope you are, use the word magnitude, because it's not always just the speed and the direction. Okay, so let's go on to our next slide. Okay, so up till now, we've been looking at xt graphs that have straight lines, whether they're up or down or horizontal. Now what we're going to look at, when we have a distance time graph and it has a curve on it, what is that telling you? And a curve could look like this, or a curve could look like this, or it could look like that. But what that's telling you is that the slope, where it's exactly the same all along this segment, the slope is constantly changing. So our velocity is constantly changing. So from our video, we see that if we have a changing slope, that means we have an acceleration. And by definition, we get acceleration is change in velocity over change in time. So this is one for the notebook. All right, so we're going to play around with this, but you can see if you hold your pen up along this curve, you'll see that it's constantly changing. And then it's constantly changing this way. This way, the slope's getting steeper and steeper and steeper. This one, the slope is getting smaller and smaller and smaller. So we're going to see what that means. Okay, so why don't you try this one first? You're going to make a sketch. And we can say that our 0 point right here, our origin, we can say that that's home. And then let's say school starts here. So when you go through this, I want you to try and sketch what you think you see here. So pause the video and try out that sketch and submit it on the Nearpod. Then when you're finished, just unpause and check it out. All right, so we're going to start at school. We're going to move with nice constant velocity till we get home. Then, let me change the color. So we're going to go from from school to home. Then we're going to stay put for a little bit. Then we're going to go faster back to school, so that's going to be a steeper line. We'll sit for a second, and then what we're going to do is we're going to accelerate home, which means we're going to have a changing slope that's going to get steeper and steeper. So it's going to look probably something like that. So as long as you're in the neighborhood of that, then we're good to go. And next. All right, so now if you think back when I said when we first started doing graphs, that a good idea, the first thing to do when you get a graph in front of you is to jot down, hey, what type of graph do I have? Normally it's xt. Normally the slope is going to give me velocity. Normally a horizontal line means no motion, but now we're looking at VT graphs. So over somewhere on the side, make a little note. Oh, this is a VT. This graph tells me, instead of where I am, it tells me how fast and what direction. And then the slope tells me if I have positive or negative acceleration. So you want to kind of take a minute or two and you want to start mapping out your graph. Now you might think, no, I got it. But I'm telling you, it gets confusing. So if you look at this, we're all in the first quadrant for data. So that means that all of these velocities that are in your graph are going to be positive, which means you're moving just to the right. So here, this segment, I'm going to say, oh, that's a positive V. This is also a positive V. This is also a positive V because we're not looking at the slope yet. We're just looking at the velocity. And to read the velocity, you just go over to the line, you come over here. Look, that's positive. Look, that's positive. Look, that's positive, etc., etc. Even here, this is still, if you come over here, that all of that is positive. So then your next step is to look at the slope. So your slope, this whole segment has a positive slope, so it's a positive A. This whole segment has a zero slope, so your A equals 0. Well, when our acceleration is 0, then remember, I like the shortcut CV for constant velocity, just as a reminder. Here, negative slope, negative A. And then here's where the magic comes in, whether or not you are speeding up or slowing down. Look at the plus V plus A. See how they're both pluses? They're both positive. If they're both the same direction, then that means it's speeding up. So here, speeding up. This has no acceleration whatsoever, so we know it's constant velocity. This has a positive velocity and a negative acceleration. So if they're opposite signs, then what's going to happen is that that's slowing down. Okay. So go through those steps when you first get it. Another great thing that we can get from a VT graph is going to be the displacement. So if you look at this, and we know that our definition, hold on a sec. We know that velocity is change in x over change in t. So let's move this around a little bit. What if we were to multiply velocity and time together? Like, what if we were to look for the area underneath this quote-unquote curve to the x-axis? If we looked at the area, then what we would be doing, the area of a triangle is 1/2 time and then this is our change in velocity. So if we got that area there, then what that's going to do is give us the displacement for that region for this time. So area gives us displacement, or delta x. This one's a little bit easier. This is just our change in velocity times our change in time. So that would be the displacement during that time interval. And then we have another smaller triangle over here. So you would do the same thing. You would use this 1/2 delta t delta v. Okay, so we're going to try it. Why don't you try and calculate these and then come back and check it over here. Okay, the one thing is, if it's in quadrant 1, if your whole graph is in quadrant 1, then all of those displacements are positive. Because remember, you're just moving to the right when you're in quadrant 1. We're going to get to a graph where it comes down this way and we have information down here. Okay. Okay, so you're going to use this graph. You should be able to click on it to make it big. And I want you to figure out the acceleration of the object between 8 and 10 seconds. So you would want to mark first, get a grip on the time interval, figure out, oh, okay, that's a triangle. So figure out your acceleration in this time interval. First off, hopefully you see that it's a negative slope, so you should be anticipating a negative number for your acceleration. So that's a hint. Pause your video and click it back on when you are finished. Okay, so 8 to 10 seconds. We need the area, remember, from here to here. So I'm going to say my displacement is equal to my 1/2 delta V over delta T. So if I use this as my final, I'm going to say it is 0 minus 8 over 10 minus 8, and my delta x is negative 8 over 2, which is negative 4 meters per second per second. And I'll talk about units in just 1 second. But that there tells you your acceleration. All right, so the units of acceleration are meters per second over second. But that's a really weird way to write it. We write it like so, meters per second squared. So what that's saying is that for every second, this number that's out here, whatever this number is, you're going to either speed up or slow down by that many meters per second. And you'll get a grip and a handle on it the more you practice. Okay, there's another one coming up. what is the displacement of this object? So if you want the total displacement, first you have to kind of look at all the different shapes you have that you can divide it into. And you will divide it obviously into this light blue triangle and then this darker blue triangle. And then since they're all positive, then we're going to just add them up. And your distance and your displacement will be the same. Okay, so pause your video and then come back and check it out. Okay, so hopefully you came back and you saw that you got 64 meters. And you can always rewind that video and check out the math that goes behind it. Okay, we have another one. Now, this one's a little bit different if you notice. So in your notebooks, I want you to put this example in here and we can start talking about it. First off, you want to look and you want to say, oh, my time is not in seconds. As long as these two axes are the same, meaning this is in meters per minute and this is in minutes, then you're fine. You can just leave all your calculations in minutes. But what I want you to do is I want you to remember the steps that I said to go through and take them really seriously because it really will help you. First of all, identify the graph that you have. You have a VT graph. So that tells you how fast and what direction you're going. And then you want to kind of get a feel for what quadrants they're in. Remember, anything that's up here is a positive V. Anything that's down here is a negative V. And of course, the positive just means you're moving to the right or in the positive direction, and the negative just means you're moving to the left. So you just read your speed and direction right off the graph, right off that line. And then remember that your slope gives you your acceleration. So this is what I say for velocity graphs. I know it seems kind of redundant, but you'll see why. Positive V. If it's horizontal, hopefully you remember that that's a constant velocity. This here to this point, I don't know why my pen changed. To this point, this line, still positive V because it's in that upper quadrant. Down here from this point to this point, that's negative V. This is still negative V because we're still down below. Good. Now you go back and you look at your slope. This is a positive slope, so positive slope means positive A. Horizontal means zero slope, so your A is equal to 0. This part here, negative slope, negative A. Still the same, negative a. That's still the same acceleration. That's still value, that magnitude and direction along this whole line is exactly the same. Slope over here, positive a. Now you want to go and you want to match up your signs. Remember, anytime they have the same sign, they're speeding up. Anytime they have opposite signs, they're slowing down. So we can think slowing down over here, speeding up. This here, be careful, both negative. So that means it's speeding up. And then this, they're opposite, so it's slowing down. There's one other really important thing. Anytime your line crosses over or gets to this axis, what that means is that your velocity is equal to 0. So you're momentarily stalled right here. Okay? So there's a lot to take in. So planning it out, really, although it takes a couple minutes, planning it out is going to save you so many headaches. Please trust me on that. All right, let's close this guy. It is giving me a tough time here. There we go. All right, so at this point, I totally forget the question. Between 10 and 15 minutes. What's the car's acceleration between 10 and 15 minutes? So you would come up here and you would say, oh, the acceleration, that's a slope. Oh, that's a 0 slope, so my A equals 0 for that question. Try this one. Calculate the distance traveled and calculate the displacement traveled. This is our last slide, our last exercise. I just went through, and you should have it in your notebook, hopefully, all the different points of interest and whether or not we're positive or negative. So same thing with distance and displacement. Let's look at this. Displacement. Remember, displacement can be positive or negative. Our distance is always positive. So what you're going to have to do is you're going to find the area here and the area here. So your displacement, anything up here, your delta x will be positive. Any shapes down here, delta x, will be negative. So I want you to try and go through this. Remember, break it up into different recognizable shapes. So here you'll have region 1, you'll have region 2, region 3. This has 2 cute triangles. That will be 4, and that will be region 5. Remember, when it's distance, you're going to add. When it's asking for displacement, you're going to subtract. Okay? All right, so try that out, and I'll post it on our page later on. Remember that there is one Mastering Physics Part 1. It's only 2 questions. They have multiple parts to them, but there's 2 questions just as a review on a few things. So get those done. It's open until Wednesday night. Also, finally, if you have not completed your quiz, it's going to close back up tonight. So if you haven't done it, get in there and do that, okay? All right, thanks a lot. Sorry for the delay. I really don't know where this Nearpod disappeared to. All right, thanks. Bye.